Hi, my name is Sarah Satish Masi, and this is my presentation for PBL3 Game of Nim. What is Game of Nim? In this game, two players take turns removing tokens, one by one. In my solution, 2 to 5 piles are randomly generated containing an overall of 2n plus 1 number of tokens, where n represents the number of tokens. In my solution, the player to take the last solution wins. This is normal play. This game is based on combinatorial game theory, where the game is not dependent on chance or randomness. It has a finite number of moves and does not end in a draw. The mathematics of this game states that the winning strategy is to always finish one move with a nimsum of 0. If the nimsum of the game is 0, then whoever plays the next move will change the nimsum to a non-zero value. If it is non-zero, then this can be changed to a non-zero value or a nimsum of 0. Consider a pair of scales. When the scales is not in a balanced position, then you can either put it back in a balanced position or tip it further and create an unbalanced position. However, if the scales are already balanced, then the only option would be to disturb the balanced position and tip it over. This is how Game of Nim works using NimSum. I have created my program in C#. It works on the basis of XOR of binary numbers. XOR is exclusive OR. If two inputs are same, the XOR is 0. But if they are different, then the XOR is 1. This slide contains the logic for the decision making for the computer. While this pseudocode is very basic, I have explained the program in my report and have put comments in my program. However, the general logic for the computer is to check the state of the game. If the nimsum is 0, then it is losing and will make a random move. Otherwise, it will check the valid moves and convert it into a binary. And then it will find the nimsum using XOR as explained earlier and return the nimsum of the proposed move. If the nimsum of the new move is 0, then the computer will make the move, otherwise it will check the next move. The nimsum of two decimal numbers are found by creating a list of binary numbers. This list contains strings. So finding the XOR of the binary list would go by taking the first letter of the first string and the first letter of the second string and converting those letters into an integer. And then the XOR of these two individual digits is stored in a new string called nimsum. And then the second letter of the first string and the second letter of the second string is converted into integers, and the XOR of these two integers is found and stored in the string. And then that string is concatenated and we find the nimsum. Code demonstration. This is my program for Game of Nim. So we start off at the main function. It displays welcome to Game of Nim and initiates a new game. Next we go to game. So this one creates a dictionary. It creates a new game and gives the user the chance to play first. User. This accepts user input and checks if the user has made a winning move. If not, then it calls the computer. Computer. Calculates and makes the move when the computer needs to play. It also checks if the computer has made a winning move. If not, it passes the turn to the user. It also applies game theory. So this is game theory. Applies combinatorial game theory lemmas and checks if the computer is in a winning position or not. If the computer is losing, then it calls a random move. Otherwise, it calls check moves. This also returns the number of tokens selected. Random move. Random move makes a calculated move based on how many tokens are present in a pile. It will always go in order of piles and compares the first two piles. Depending on which pile is smaller, if it is not 0, it will take all the tokens in that pile. Otherwise, it will check other options. It returns the number of tokens selected. Check moves. This checks for all possible moves the computer can make. It selects a move which will make the nim-sum of the state 0 for the user so that the computer can win the game. It returns the number of tokens selected. If it cannot find a move, then it will call random move. Check nim-sum. First sends an empty string to nim-sum to calculate the nim-sum of the first two strings in a binary list. Then checks if piles are more than 2. If yes, then sends this result to nim-sum and gets the nim-sum of the previous result and next string in binary. Convert to binary. This adds all the values of the dictionary into a list named binary, then converts every item in a list into binary digits, then converts these digits into strings so that each decimal number has turned into a binary string of 3 letters. And nim-sum. This one performs the XOR of each digit in each string of 2 decimal numbers by converting each digit into int and applying the XOR operand. This returns the nim-sum of each digit concatenated to a string of 3 letters. So that's the explanation for every method and function I have. Let's play a game of nim. Okay, we have 3 piles and 14 tokens. So let me choose the third pile and 1 token. So the computer decided to choose the first pile and take 3 tokens. So now I have now the first pile has 1 token. So second pile 4 tokens. So the computer decided to take the third pile and 4 tokens, so all the tokens. So now I'm clearly losing. So if I take any pile, for example 1, and choose 1, then the game is over and the computer wins by taking the last token from pile 2. So this is the results for a game where the computer generated 2 piles with 5 tokens. And in this case, the user won. Limits and constraints. So in limits, the maximum number of tokens will be 7, as binary conversion is only 3 figures long. User makes the first move. This is hard-coded into the program. And to exit the game, the only way is to close the terminal. There's no option to select close or enter close to exit the game. Learning outcome. So this task was very informative and I learned a lot of things. Mainly, I learned about combinatorial game theory, nim-sum, the use of XOR operand in C#, and creating a game tree. Thank you.